Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Haizan bin Azman and I'm from CS2456A and my supervisor is Dr. Siti Rahayu binti Abdul Aziz. So I'll be presenting about my project which is Proactive Diabetic Patient Monitoring System with Geolocation. So we get to the next part which is introduction. Having a healthy body is the biggest blessing for every people in the world. Diabetes mellitus is an anabolic disease that results high intensity of blood in sugar in blood. High blood sugar from diabetes can damage the nerves in your body that help keep your blood pressure steady. So, the rapid growth of ICT makes it possible to develop a new kind of medical monitoring system. So, we get to the problem statement, which is the first one is most of the diabetic patient is lack of knowledge. So, they need to have knowledge about diabetes. The second one is they consume a lot of time to go to hospital if they don't have any diabetes measuring device. So they need to go to the hospital just to measure their sugar level. So the third one is low effectiveness on delivering information. So patients who low on blood glucose will feel dizzy and lightheaded because them too hard to talk to emergency services through phone call. So we get to the objective. So the first objective is to develop a proactive diabetic patient monitoring system with geolocation. The second one is to evaluate the accuracy of geolocation implemented in the system. So we get to the scope, which is the user. So the first user is diabetes patient, and the second one is emergency responder. So what is the function of this application? It gives knowledge and monitor blood glucose level and proactive notification for emergency responder. So this project is developed on Dart, Flutter, SQL, PHP, and C. C, which is Arduino. So, for my literature review, my finding based on what article that I read. So, the first one is about diabetes. Type 1 diabetes. Type 1 diabetes is a severe autoimmune condition with insulin loss and hyperglycemia arising from it. Over the past 25 years, knowledge of type 1 diabetes has grown exponentially, contributing to a wide understanding of many facets of condition, including its biology, epidemiology, immune and beta cell phenotypes, and the burden of the disease. So, diabetic ketoacidosis, it happens as the body begins to break down fat at rate that is much too high. The liver transforms the fat and cold ketones into a fuel that cause the blood to become acidic. So, if they transform into ketones, our body also will discrete acetone, which is through our breath. So, ketones are compound that exist in the body when body fat is used for energy instead of glucose. So what is IoT, Internet of Things? The Internet of Things is a significant subject in the field of technology, policy, and engineering, and has been top news in both specialist press and mass media. So we get to the next part, which is the device I use in this project. So the first one is I use Arduino Uno R3 as the microcontroller. So the second one is the crucial part, the crucial device, which is ESP8266, which is the Wi-Fi module to connect to the Wi-Fi to send data to the tape to the database. So the third one is TGS822, which is gas sensor. I use this to detect acetone concentration in user's breath. And the last one is HT11. It is used to measure the humidity and the temperature of user's breath. So we get to the next part, which is about the networking and methodology. So all the devices are connected into the same network, which is the first one, the IP address of a gateway or the server for the mobile application to make request to database, which is the IP address is 192.168.0.25. So the middle one is the diabetic measuring device connected to the network, and the name is ESP228251. And the last one is for the mobile application. The smartphone is connected to the same wireless local area network as the server. So it is on the same network as the server. So this one is on the same network. So this is the system architecture. For the first one is the blood glucose monitoring system. So when the user uh, wants to measure their blood glucose, so the first one is they will exhale their breath, and then the Arduino will process the data, and then it will send to the ESP8266, and then it will be sent to the SMPP server with the help of PHP, and then it will retrieve the data. It will pass the data to the MySQL server. Once the data is set on the database, the database will pass the data to the PHP server, and then it will be displayed on the mobile application in smartphone. So the second function in the system is the tracking system. So the first one is when the user activate the emergency function, it will request the location from Google Map Geolocation API. And then when the request has been approved, the data in the form of latitude and longitude will be stored in the database. So once it is stored, the data will be fetched through internet and will be displayed for the emergency responder on their device. So they will see the location of the victim, of the user if they having an emergency. So the system demo. Let me show how it works. So we get into the system demonstration part. So the first one is I will show about on diabetes monitoring app. The second one will be emergency notifier app. So we get into the diabetes monitoring application, mobile application. Okay, so at here we need to key in our username and also our password. So if we don't have an account, we can register by clicking on the sign up button, and you can use after you register, you can use the application. So we log in into the application. So name is Haizan and the password is 1212. Sorry, 1212. But if purposely I type wrong password, it will show this valid username and password. So I type wrong password, the right password. Okay, on the homepage, it shows the information about diabetes, so user can read from here to gain their knowledge. So the first one is about the diabetes and also type of diabetes and also more or less about diabetes. So we get to the main function, which is to measure your diabetes. Okay, for this one, we need to open serial monitor from Arduino to show how the process is working. So I open the serial monitor. So right now it's connecting to the Wi-Fi. Oh, okay. So it's been connected. The IP address is 192.168.668.78. Okay. After the sensor has been warmed up, so I need to blow into two sensors, which is the gas sensor and also the GHT11, which is the humidity and temperature sensor. So I will blow into this. So it get my reading of acetone. So the device will stop running and the device is powered back on. So once the reading has been submitted to the database on this application, we just need to press get. Okay, when we press get, this will show, and as we can see from here, it also my acetone reading, and it will appear on this device, on this mobile application, and it will show the reading in millimole per liter, and the advice is continue your healthy sugar intake and practice healthy lifestyle. So we get to the next part, which is the emergency geolocation function. So for this one, we need to access to the location. So what is the app? So the location has been submitted to the emergency responder. So we see into the uh, second application, which is on the emergency service notifier. Okay. So my location, which is acquired just now, which is on 10 p.m., 10:49 p.m. as you can see from the clock, and the date is 1st of August 2021. So for this emergency notifier app, we can know the location of the victim. Okay, so open the Google Map. So we know the current location of mine. So by using this function, the emergency services can get the location of the victim easily by just press the direction button, and they will go to the victim's location. Okay, for the next part, I will show on testing, which is I think that you might be wondered how the reading has been taken in acetone. So on my reading, I use millimole per liter. But from the source I get online, on the trusted source, this one is the chart. I mean the breath acetone, which is the diabetes ketoacidosis. As we can see here, it is the point where the acetone has accumulated in our body, or the ketone. So from this one, it shows us on around 100 and below. So from that, I convert the reading. This one is on particle per mole. So I convert the reading to the millimole per liter. So as you can see here, I make a conversion between it from. So as you can see here, I make a conversion from particle per mole to millimole per liter, which is on the first one is the ppm for 100 ppm, as previous image we see 100 ppm is the minimum level before the diabetic ketoacidosis will begin in your body. So the molar mass of acetone is 58.08 gram per mole. So if we convert to millimole per liter, we can get 1.72 millimole per liter as the limit of somebody that will, as a limit to indicate that their body is lot of sugar. So we get to the next part. Sorry. The next part is I make a testing on 4 volunteer. First one is male, 53 age of years old, and and he has mild diabetes type 1. So all the subject is not fasting, and the volunteer B, volunteer C, volunteer D has not. Uh, they don't have diabetes type 1. So we get to the we get to the result test. So this one is volunteer A. As you can see, the first reading is 1.78 millimole per liter, and then the second reading 1.8 millimole per liter, and the third reading is 1.77 millimole per liter. As you can see here, the volunteer A has passed the limit of diabetic ketoacidosis. So uh, this shows that volunteer A taken a lot of sugar today. I mean on that time. Okay. So volunteer B, volunteer C, and volunteer D shows a good sign, which is on below 1.72 millimole per liter. So for the second test, I make a reference point, which is I set a location of mine on the Google Map and I get the coordinate. And then for the variable, which is the changing variable, is the coordinate I got from the emergency function. So I activate it 5 times, and those coordinate I got, and I use online calculator, which is on the calculator to calculate distance between 2 point, two coordinate. So for the first test, the distance between the reference point and the location obtained is 1.7 meter. And the second one is 5.2 meter. The third one is 3.3 meter. And the fourth one is 2.4 meter. And the last one is 1.8 meter. And the average of distance between the reference point and the location, sorry, on the location obtained is 2.9 meter. So as we can see here, the range is pretty low. So the testing is a success. So we get to the conclusion of this project. So if there is a time on the future that could be used to develop this project to a better level, I will sure will implement some function which is more significant for the user. So the first one is a better coding algorithm for data security, which could encrypt users' data during transmission to the server and vice versa. Will also be considered for the future improvement. So for the second one is a function which can gather all the previous data from the past readings. Could also be considered as the user can know how their blood sugar level was at. So if there is time in the future, this recommendation will be implemented. So we get to the next one, which is the conclusion. So for the conclusion is this project aspires to be a part of the future solution for the medical technology sector, assisting with non-invasive diabetes measurement, which is we don't need to prick our finger to get the blood and measure our sugar level from the blood, but we use our breath. And emergency radiolocation for emergency services, particularly ambulance service. One of the project's benefit is that it has a pleasant and user-friendly graphical user interface (GUI). This is due to the Dart programming language and its framework Flutter, which we use to develop the mobile software. So I think that's all for me. I hope you get an information from my presentation. Last but not least, thank you.